to perform some analytics of an organization, right? So an organization might have their data on the database server. As a data scientist, you have to interact with the database, try to get information, try to extract information, and try to, I guess, produce some analytics. For example, if the database contains the customers and your job is to predict, right, which customer is going to churn or to cancel the subscription, right? You have to find out information, right? What are they doing? What they are? How often they are interacting with the service, right? For example, if you are a data scientist and you work for Netflix, for example, which is a movie streaming, right? So Netflix may have a database of customers, and they know each customer, their background, and most importantly, how often they stream movies, right? Maybe they stream every day, stream once a week. What their taste is like, what type of movies they are watching, right? There are different marketing strategy, marketing purposes. If you are interested in knowing which customer is going to is less, interactive with the service, then you have to find out those customer, right? So, so if a data scientist, and obviously you have to interact with the database and understanding how the implementation, understanding of the implementation will help, right? So we have a concept of relation, tuple, attribute, right? So there are table, rows, and column. It might be easier to understand. Then, so this is another way of another example, right, of a typical schema diagram for a university. So we have different entities. We have classroom, section, time slot, course, student, department, advisor, instructor, and text, right? They are interlinked, to each other, right, in a special way, according to design, according to the relationship. All right, and if as far as the relational model is concerned, there are a number of operations that could be used. For example, selection, projection, natural join, Cartesian product in unit. So depending on what exactly you are requesting a database, and you have to choose the operation accordingly. And that can be done through a very specific language called relational query language. So for those of you who already play around with SQL in the practical, yesterday, you already know that this is an example of SQL select something from something, where from something, right? Whereas this is different attribute relations and predicates. They are the specification of particular statement. All right, so there's a Vincent saying, how do we access the SQL in the tutorial? Yes, you will know that, but yeah, you ask us questions, and I pop up this thing here. So as we tell people in this in the practice yesterday, you don't have to install DBMS software on your computer, because they tend to be large, they tend to be complicated, and we just want to have a very basic knowledge of SQL, so we can just get to some free online SQL interpreter, right? So if you click on this link, you will see something like this. Let me share with you the screen. So where is it? Okay, how can I share the screen? Share the screen, Chrome tab, was it one? Hopefully. Okay. So this is the one that you're going to have to do in the left, right? So as you can see from here, where is it? Okay. Oh, can you see? All right. So if I click on that, of course, if you click on that, you see something else. But this is actually the practical exercise. Okay. So you have to write something like this, right? And then if you run this, right? Once you finish that, you click the execute button, which is here. Then first of all, you can see that you can create a table which look like this. All right, and the next task you have to do, right, from a data mining perspective, is that maybe there are two classes, male and female, right? So what you want to do is that maybe you want to extract all the sample from the male class and all the sample from the female class for your own evaluation, right? For your own understanding, for your own analysis, and trying to understand, the distributions or the statistics of the data, right? So you have to write two statements, right, or two commands that can do that, right? So it will look like this: select, right? So the question say name, age, and zip code, right? And you have to say from test where gender is equal to this. So this is exactly what we see in the slide, right? So once you had hit example, it will just produce something like this, right? And of course, maybe you can even, like, for example, divide something where and, for example, age, for example, is less than 30, for example. Sorry, less than 30, for example, right? So, sorry, age should be, I'm not sure if the case, but just let's say, for example, execute, for example, then you can see now it becomes 11, right? So which is less than 30, but previously there was an entry with the age of 31 less than that. So it's more like if you are interested in certain attributes, certain condition, then you can interact with the database and get the information from the database accordingly, right? Later on, then you will know that it's basically we have some sort of feature selection, feature extraction. So that's the thing that you will need to do. Okay, so I hope that answered your question. In the practice, we'll go through that again. All right, coming back to this. Okay, maybe I have to switch another user so I don't have to go to this again and again. Okay, where are we? SQL command. So some people have asked me before, what's the level of SQL that you are expected to know? My answer to that is that everything is listed in here. So something like data definition, we have three different statements: create, drop, and alter, right? So you have to understand when you have to use each of the commands. Create when you create new, right? Drop when you remove commands, views, tables, and databases. Alter when you modify a schema, right? But the main focus is on data manipulation, especially select from where, right? So from a data mining perspective, that is what I would like you to know in a bit more detail, right? All right, so and then in the slides here, 48 to 49, 50, there are some example, right? So what I would like you to be able to do is to understand this example, and from there you can complete the exercise one in the first practical. All right, so that's all that I expect you to be able to understand in the first workshop. Now, is there any question before we move on to solving tutorial questions? Okay, so let's move. If no question, then I move quickly to the tutorial question. All right, so my aim is to cover as many questions as possible. No, sorry, I got the wrong one. I got to share. I aim to cover as many tutorial questions as possible. But if we are unable to finish all, maybe there's one or two left, then I hope that you could try to attempt the tutorial questions outside class. And if you have questions, then please post on discussion boards, right? Or if a short question, there, then go to Discord, right? Hope that. All right, now let me double check, right? For those of you who attended the workshop last week, I think question 1 is done, question 2 is done, question 3 is done. I think Question 4, I think it's done, right? Correct me if I'm wrong. Question 5 is done. Questions 6 is also done, right? I think the first part is done. All right, unless you have any requests, and I will move on to question 7. Describe 2 disadvantages of a database system. This is for question 1 from chapter 1 of the textbook, database management system. So I think about a database system, even though it is good, right? It's secure, it's solid, you know, it has lots and lots of advantages. But what about its disadvantages? Can you suggest 2 disadvantages that a database system might have? Compare, right? So disadvantages, when we talk about disadvantages, we talk in relation to maybe some simpler scheme. For example, if you, instead of have a database, you have an Excel spreadsheet, maybe that's the all right. So we have a response here from Chad. Yeah, it's complex, time consuming to set up, right? It requires knowledge how to use it. Yeah, that is definitely one disadvantage. For example, if I remember, I conduct a survey, right? I conduct a survey about your preferences of the lab session, right? I just send you a link to the Google spreadsheet. I mean, if I set it up as a database and you have to enter, you know, username and password to log into it, and I guess enter your preferences. I mean, it's more secure, it has more feature, but as far as the objective is concerned, maybe that's a bit too much, right? So maybe in that case, maybe a simple alternative is better. So maybe the spreadsheets. Less qualitative data. I don't know what you mean, Callum. I mean, unless you explain, I guess database can capture anything, right? Anything that you can store or capture in maybe a text file or an Excel file. Then a database can also capture those things. So not sure what this means. Yeah, so we have from William here. Yeah, it can take a lot of resources set, right? Oh, yeah, okay, yeah. I'm not an expert in database, but I know that it's not easy. There are lots of things to tweaks, and yeah, definitely it's a lot of effort. So obviously, yes, you have identified the setup which require the expertise, right? And as I said before, database tend to be very complex, and when things come to complex, maybe depending on the job, if the job is if job is not that, you know, complex, then maybe database could be something overkill. Yeah, changes in schema could have unforeseen consequences. Yeah, maybe what it means is maybe less flexible. I think it may be the same thing as what Chad has suggested. Less flexible when you set it up. Maybe you have. So that's why you have to design very carefully at the beginning, right? Yeah. So thank you very much, Carbon, William, Chad, and Callum for your input. I think what you have described there are totally relevant to this question. All right, now if you have a look, let's move on to question number 8. 6 major steps that you would take in setting up a database for a particular enterprise. I know this question might be hard if you haven't done anything to do with that database before, but let's stop for a moment and think. Imagine if you need to take up a database for a particular enterprise. What do you think you should do first? For example, right, maybe database is something. All right, yeah, okay. So, Chad, I'm not sure if, yeah, if you are, I'm not sure if you are a software engineering person or not. But one of the things is that you have to understand the requirement. What exactly the customer wants, right? I think that's a very good answer. For example, if you have been asked by a friend or by a relative, right, install an operating system for my computer, right? So you gotta understand what is the objective first. Is it a like a personal use, or is it a server, right? Is the person less familiar with where was the sort of IT sort of literacy, for example? Is someone really sort of tech savvy, or is someone really have beginner, right? So you have to understand first, and you understand what sort of security requirements. So understanding the requirements is, I guess, the first thing you have to do in order to deliver something that meets the requirements, right? Okay, so I guess requirement is the first step. What should be the second step? Once you understand the requirements, right? You understand, like, for example, different departments, different courses, right? Yeah, conceptual design. Yeah, then you start with a conceptual design. That's what the ER model is all about. Starting with different entities, right? Trying to identify different attributes. For example, lecturer or instructor, you have name, ID. You have to find maybe the primary key, things that uniquely define each entity, right? So the modeling. All right. What about the next step? Once you have come up with a conceptual models, you can capture the type of data, and you can capture the relationship between the entities. What do you think you should do next? Yeah, maybe something to do with the both of you are correct. Yeah, maybe storage requirements, schema, phraseological schema. See what are you going to do with that? Yeah, so that's the. All right. So once you have the physical level storage requirements, how you map the database to different storage devices, right? What else that you need to do? Yep. Yep. Okay. You might do some stream refinement that's on top of that. Yeah. So that's that's also no. Yeah. Okay. What else? So you set things up. Instant things are, yeah. Okay. Yeah. User. Yeah. That's what I'm looking for. User. Right. So user. Maybe you have to identify who actually going to use the database, right? And what sort of functionality should we provide? So you have to identify that. So you may have maybe an employee accessing a database, or you may have an web applications that access the database and then, you know, display the information on a website. Administrators, analysts, for example, and maybe each of them will have different requirements, and you have different interfaces. Yeah, that's right. And finally, yeah, and the final step is obviously to create and initialize the database, right? So these are the steps clearly described in the textbook. So for those of you who are interested in knowing further about these steps, I think you can find information from the textbook. All right, let's now move on to question number 9. List at least 3 different types of information that the university would maintain beyond those discussed in the lecture, right? So what is those in the lectures? Maybe those in the lecture is those in the slides that I mentioned. All right, so what about 3 different types of information that from a university point of view it would have to maintain, right? So in the slides, I'm not sure if you recall it. I don't want to switch between back, but we have something like lectures, instructors, courses, texts, what do I call it? Text. Maybe I have to bring it back. Text. Let me try to get. So in the if you look at the slide 42, for example, you have no, not this one. slide 44, right? You have section, classroom, teachers, time slot, course, prerequisite, instructor, department, advisor, students, and text, right? So these are the information that were mentioned in the slide. Oh, different types of information. Maybe what I mean is basically, how can I say? I probably refer to different entities, right? Things that not really mentioned there at this stage. So type of information, like maybe refer to entities here. Yeah, maybe it has to do with maybe have you got something to do with students yet? Let me double check the slide there. We have students, we have courses. Yeah, I think we haven't. I think figure 2.8 or on slide 44. I think we haven't mentioned anything about assessment yet, right? Assessment and records. I think not there yet. So I think that's a very good suggestion. Assignment, right? Callum, you suggest graduates? Yeah, graduates. Graduates, I'm not sure. Could it be part of students? Yeah. Yeah, maybe that. Maybe yeah, you probably have to. A student who graduate, maybe you have to yeah to put them into. To maybe another entities, yeah. Okay, so and courses, I think we already have unit and courses, right? So you have course there, we have units as the same. So if someone suggests libraries, yeah, maybe our libraries, yeah, electronic libraries, things that students need to make use of, right? Informations about room booking, Jack, yeah, that's great. Room booking, yeah, we need to do we have actually room booking already? So we have time slot. Yeah, it's related. Maybe I suppose, but maybe another room booking. Yeah, that might be relevant. Yeah. Anyone suggested? Yeah, account. Yeah, something to do with finance. Yeah, obviously finance is the most important part of the university, so it should be there. I don't think it's there at this stage. Yeah, maybe something to do with finance, payments, and yeah. Okay, buy lockers. I'm not sure, Kevin. Buy lockers. I'm not sure this part of the something that could. Yeah, maybe it belong to properties. They may have some information about different assets. Yeah. Oh, really? Okay, I didn't know. Yeah, I do not know that there's some buy lockers assigned to student number. Wow, it's new to me. All right, maybe that's something that the university offer to students, right? All right, so that's just an idea, right? So hopefully that could give you an idea of other information. So what I would like you to do is think about example like this, right? So if you see a question in a real world, in the test, that if I ask you, for example, think about this organization and identify, different entities, and you should come up with something that makes sense, right? Something that's convincing. All right. Question number 10. I use this question number 10 in the last year exam, but it turned out that after the whole semester, some people actually forgot the first question. Sorry, the question in the first tutorial, right? So let's have a look. Question number 10. So you have queries used in web search and queries that you in database, right? The questions is, can you explain differences between the two types of queries? In particular, the way the queries are specified, and secondly, in terms of what is the result of a query. All right. So you, I believe that many of you have performed internet searches on a regular basis. You're looking for information. You don't need to know SQL look for information that you want, right? Somehow, I guess Google or Bing or whatever search engines, they are quite smart. They yeah. All right, so we have something. I think one is, all right, so the first one is in terms of the way the queries are specified, right? Then I think, Jeff, you just mentioned there, on Ben, you mentioned there that one is free text, you can enter whatever, right? But with queries that are specified, right, then the queries, then if you make a mistake, for example, it will have an exception or an error straight away, right? Whereas if you misspell, for example, if you misspell curtain and I never tried before, but if you spell Curtin University, but you misspell by a character, right? Then somehow, I think Google engine is smart to recognize that you have to make a mistake and you still return, in the list Curtin University. Whereas if you have a database and you looking for the attribute name, for example, is curtain and you misspelled it, right? It won't give you anything, right? That is for sure. Database is very specific. It has to be exactly matched, right? I haven't heard of any database that is, that is smart in the sense that it accepts misspell of the values, right? So what you guys say is that the queries have to be in a proper language, right, in a specified way, in order for the database to understand, right? So and one is free text and the other is not, right? So you have, all right. So in terms of the result of a query, right? What can you say about the differences between the two in terms of the result that you receive? Can anyone explain in a little bit more technical way? Yeah, thank you, Hart, for your input. Yeah, suggestion versus error. So with web page, if we type in information, right, behind the scene, I'm not sure you heard of something called PageRank, right? So Google is based on something called PageRank, which is basically a score, right, of the relevance of an entry in the database with respect to the query, right? And then they rank the relevance there for you to choose from. So this is what the engine thinks that is the best match for the query. However, it just contains a list of, I guess, a list of websites, I suppose, right? A list of websites that it thinks. Whereas in database queries, the result that you get, basically, they are tables, right? They are table that I select from, always give you a table. And most importantly, the results are basically accurate, right, or specific to the query that you have, right? For example, if you look for AV for all the entries, the particular name, for example, it would definitely return entry with the exact name, right? Nothing less, nothing more. Exactly. For example, you're looking for maybe data mining, for example, return all the books with the title has the word data mining, so it will definitely return all the books with data mining, and not something like data analysis, right? So it has to be data mining if you look for data mining. Okay, so that's the in terms of the results. Okay, now we can move on to question 11. Construct an ER diagram for a car insurance company, right? Who customer own one or more car. Each car has associated with it zero or number of record accident and so on, right? I give you 1 minute to read this. I'm not sure if anyone has attended this exercise before. If you have attended the exercise before, I'm more than happy to let you explain your solution or your answer to this question. Okay, so what I'm asking now is that for the question here, what I would like you to do is to identify the entities, right? What are the entities that you could find in here, and then can you identify the relationship between the entities that you have identified, and then you can specify the type of relationship, whether it is, you know, one-to-one, one-to-many, or many-to-many, right? So think about that, and then you can you come up with some suggestion. Okay, so the first is that all right, so I have something called customers. Yes, we have customer. Yeah, customer basically is an entity. That is correct. Yeah, so somewhere in the question we have customers, and customer can own whose customers could own one or more cars, right? So we need to have cars. That definitely we have to have cars because customer own cars. They are real entities. All right, so we have another payments. Yeah, payment is definitely it's definitely something something that that should be there. All right, so what we have, chat say claim, yeah, policy, yeah, Olivia, yeah, I think your answer is good. Policy, there should be some policy. If you ever have a car and you have an insurance, right, then it always give you something called policy, and every policy had some, I guess, some identification number with the policy, right? You have a number. Yeah, the policy should, the claims, I think claims should be actually part of the payment or under the policy, right? I'm not sure if claims should be. Yeah, okay, maybe William, yeah, maybe claim probably associated with an accident. Probably an accident is probably from, because this is from a from the car insurance perspective, right? That maybe they maybe yeah, accident claim probably sit within an entity, right? Accident record, maybe that's definitely something that that is, you know, I guess suitable. Yeah, so at least I have identified customer, car, right? Someone mentioned policy, payment, and accidents and claims. Maybe they should fall in one entity. All right, so is there anything else you could suggest? Okay, I think Chad, your question is about insurance company. I don't think I don't tend to think that they share this shared database in terms of implementation, right? Maybe they have the interface that they that they might communicate, but I don't think they share the database. Yeah, I'm not quite sure. So as far as this question is concerned, we are only we are looking for a ER diagram of one insurance company and not all of them. Yeah. All right. So exactly, yeah. So you can only claim for one policy. You cannot claim for multiple. Yeah, I mean that maybe that's insurance works. If you have different policy, then yeah, the same event you cannot claim. I mean that's maybe that's how they word the policy. All right. So I guess, of course, there might be not a unique way to design this, but at least I can identify some common answers among among those of you who have provided, right? So let's talk about a customer and car, right? Let's just say some customers and car, obviously they are two different entities. They are relevant in the context here. So I have an entity called customer. I have an entity called car, right? What do you think the name of the relationship between customer and car? All right, so many of you actually choose one to many. Okay, so that's definitely one view of it. Does anyone have any other suggestion? Yes, so you can have secondary drivers. Yeah, chat. You yeah, many customer can have many cars. Yeah. Registration, yeah, you can have joint drivers, yeah. Rego, yeah, so you can have Rego as well, yeah. Right, any other suggestion? Definitely, one customer may have one or more cars. So, but in a in a from the and yeah, that definitely there's definitely sorry, the right answer. Right? The right answer for cars and sorry, customers and car, right? Then you then you will need to have for example a database, or sorry, a tables, right, of customers and a tables of cars, right? And then there should be a mapping between from one table to another table in terms of the relationship between them. So as someone has suggested before, right? So you can have many customers, you can have many cars. So the relationship, first of all, right, the relationship between cars and sorry, the customers and customer and cars is own, right? Customer own a car from the information given in the question here. So that one is own, right? And then you can have one number of customer own more cars. So the answer to that is many to many, right? So a number of customer owns and then cars. So many to many. Yes, Andy, that's correct. So the answer to that is how can I draw something here? Yeah, so what I would like to see is, hang on, can I draw here? No, yes. So you have a table, or not, sorry, a box, right, represent a customer, and you have another box represent cars, and then do you have a free line? Yeah, so here you have one here, one here. So according to that, right, and then what is the notations of many to many? Let me double check that's consistent with what written there. So many to many. All right. So one to one, we have an arrow. So and many you just have a line, right? So just to be consistent with the notation, just come back here. So you have this one here. Sorry, my drawing on the screen is not great. Oh, you're okay. That's a good point. A car can only have one owner. Actually, a car can have a joint owner. Yeah, a single owner can own many cars. Vice versa, one car could be owned by I mean jointly owned by two people, right? Multiple driver. So okay, so there's a question here. How can many customers own I think no. For example, two customer own a car, right? Um, yeah, I mean, I'm not sure the rule. I think. Oh yeah, so it's okay. So it's like, yeah, it's like you can have two-person name as the owner of the car from the car insurance company's point of view, right? Yeah, you have multiple drivers. Yeah, so from the insurance point of view, then if you want to map different customers to different cars. All right. So see, guys, have this. Yeah, but Kevin, yeah, that's have to not to be named, but I suppose they need to have. I suppose they need to put the. They have to record the name somewhere, right? So where is the best place to record the name? Maybe just from the table, from the entities that you define there. Yeah, well, I suppose, yeah, from the insurance, yeah, Joe, I think you mentioned, I think, practical aspects of insurance. The policy should cover the cars. Of course, there's another table right here. We have cars. Sorry, I haven't finished this. So no, here. So this is car, and this is customer. Yeah, so definitely there's another table that, sorry, where is it? Sorry, line, sorry, no. So there's another table to do with police, sorry, policy, policy, right? And then there's some relationship between cars and policy. The policy cover the car, right? But as far as the database is concerned, in terms of the implementation, you need to somehow record the customer, right? The customer somewhere in the database, don't you? Yeah. So you, all right. So yeah, okay. That's of course we can go on and talk about insurance for a long time, but yeah. Yeah, okay. That's a very interesting discussion. But all right, just go back to the okay. Of course, I appreciate you share. I guess sort of practical information about the insurance business, right? But as far as this question is concerned, right? Can we, all right? So I would say the customers and car, right? You can have from my point of view, right? The insurance company, I suppose that they need to record customer names anyway, right? And it has to be somewhere in there, right? And then you have to have a tables for car, right? And then in between the relationship between them, right? In this case is a customer own car, and you have policy, right? And cars policy cover a certain car, right? maybe one policy cover one car and so on. So between the policies and car, right? Okay, not nicely drawing, but anyway, right? Now, I couldn't find. I think I couldn't find the previous message. Right. So policies and car. What do you think? Is it? Oh, sorry, I haven't shouldn't specify this. So between policy and car, is it one to one, one to many, or many to many? Right. So we policy is defined for a car. Right. Now, okay, so the question, I think the thing there is that each insurance policy covers one or more car, right? And has one or more premium payment associated with it, right? So I haven't specified the link yet, but I'm just going to discuss, right, in the class, what do you think about the policy one to many? All right, yep, I have a couple of answers there. Definitely, right? Definitely, each policy will cover one or more car, right? Exactly, yeah. Now, one policy can cover one or more car, right? Yeah, I think Leandro, I think you mentioned something very interesting. But actually, one car, you can buy different policy for one car, right? There's nothing to stop you doing that. Is that right? Of course, it is. Someone might have a particular policy for this car, but could have another policy for another car, depending on what kind of policy it is, right? Is it actually unlikely in practice? Yeah, so normally you would say, well, I have by policy, maybe I have two cars. From the question here, policy cover one or more two car, but yeah. But in practice, right, it is also possible to have a car that could be covered by different policies. Yep. So from yeah, of course, yeah. But in well, yeah, it is specific to the description given. So okay, so if it is a many, for example, a policy can cover many cars, and a car be covered by two or more policy, then it is a many to many, right? Obviously, if that is interpreted from the question, right, which is what I think it is possible for that scenario to happen. So a car could be covered by more than one policies, and then a policy might cover many cars, similar to a customer might own many cars, and a car could be recorded in the system as own or has a name of number of for a car, a particular car, right? Maybe they are joint drivers and so on. So okay, sorry, I should have the name there. So obviously this is the own relationship, right? And this is the cover relationship. So okay, sorry, where am I? So you have customer own car and car policy cover car, right? That's first of all the name of the relationship you have to clearly identify from the context, and the type of relationship, right? will be also identified from this question. All right, so my answer to that is that they owe many to many. So 40C, many to many car, and also many to many customer to car, right? If you come up with other arguments, and I would like to hear, but from my point of view, from my interpretation from the question, a customer might own a number of cars, and vice versa, a car might be registered under the name of two customers or more. Same thing with a policy and car. A car could be covered by two different policy, right? And yep, and a policy may cover a number of cars, right? Okay, so there's a question here. What if a company owns 100 cars for its workers? Should it has 100 contracts or only one contract for 100 cars? Well, that's an interesting question. Does anyone have an answer to this question? If a company, right? A company is basically a customer anyway, right? Yeah. So I guess if you have 100 cars, then the only problem in practice with one contract for 100 cars is that if you have a car that is written off, then the contract no longer cover. I mean, you have to change the contract somehow, right? Yeah, that is, I guess that is, yeah. But I would say it is possible to have one contract for 100 cars, and vice versa. You can have 100 contract for 100 cars. I think the choice is more a business perspective, what you choose to do, right? But I think as far as this question is concerned, we are talking about designing a database that we can meet the possible requirements in practice. I think some of you actually divert the discussion to a real world sort of business aspect, which is fine, which is interesting for my opinion. But as far as the question is concerned, then if you are, so let's say if you are a database, right? Then what we are interested in is to have some design that will work for many cases. All right, yeah, but anyway, I think that discussion is interesting. So it is now 7:07. We should have a short break there for 10 minutes, and after that we will come back with I guess hopefully we can finish off the I guess how many more questions we have. Question 12. Yeah, question 12. I think that's maybe I will leave the question 12 for you to discover outside once, especially for half of the class I haven't got a chance to practice SQL in the practical, right? So I will leave that for the one until next week, and we just quickly revisit this question in the next workshop, right? But after the break, I would like to touch on the second lecture or second workshop, right, on data preparation. All right, so I will get you. I'll give you a 10 minutes break, and we'll come back at maybe 7:20, 7:18 from my time. All right, Vincent. Yeah, if you miss the workshop one, yeah, I mean, just post your question on discussion board, and I try my best to address your question. Okay, so you can post your question there. So yeah, I will help you with the answer because they are. Yeah. Oh yeah, Discord, Olivia. That's another way, easy way for many of you. All right, thank you, and I will see you in 10 minutes. Oh, did I miss some? Okay, let's have a look. 2020 lectures, data preparation. All right, so there's the question from Hashir. Can we listen to the workshop later? I think if you browse to the top of the chat here, then I answered. My answer is that I do not plan to record any workshops or practicals. If you want to listen to the workshop later or listen to the practical later, you are more than welcome to download some screen capture software. I believe that there are many of them around, and you can record to your computers. I think that's really something that you can explore. Okay, what am I doing now? All right, so question number 12. I think we need to catch up with the second lecture, otherwise too late. So if we have more time at the end, I will come back to question 12. But otherwise, what I would like to do now is move to the second the main topic of the second workshop on data preparation. Right, this is something for everybody to to be ready for the practical next week. Understand different data processing issues and how can we address those issues. So before doing so, let me just run a no, where is it? Okay, poll. So there's no okay. Yeah, if all right, yeah. If someone make a record of the workshop last week, yeah, you're more than welcome to share among others. That is absolutely fine. I just mentioned to some of you, and I mentioned to other people, is that due to the nature of the delivery here, maybe sometime I need to look at someone's screen, and it's just the privacy issue that that prevents me from recording and making the recording available. All right, so I believe that all right, there's still a large number of students who haven't watched the iLecture yet. Yeah, you whoever record the workshop, a lecture, you can post a link on discussion board or post a link on Discord, wherever, right? Wherever that other people can find. All right. So I have received 36 responses so far, and one third haven't watched iLecture yet. That is concerning, right? Let me reiterate that it is important that you watch our lecture beforehand because the nature of online delivery here. I would like to see you watch our lecture beforehand, before class. Write out your questions, and when you come to the class, you come with questions, right? Otherwise, it is not productive because I do not have enough time, right? To explain in detail the topics for each workshop. I just briefly go through the topics, and then we will focus on solving problems to make sense of the topic. All right, so having said that, those of you who haven't watched our lecture, please watch our lectures and make sense of what I'm going to discuss. All right, so in the second lectures or workshop, we look at data feature extraction, data cleaning, data reduction and transformations. These are the important pre-processing steps that you need to do in every data mining task, right? Feature extraction from raw data to something useful, data cleaning, address issue with real-world data, and data reduction transformation for a particular purpose that you would like to achieve, right? So in feature extraction, the book is there, right? The background is there, right? Feature extraction. Now, one of the key things that I would like to mention is feature extraction is an application specific and domain driven process. What it means is that depending on the problem at hand, then you have to come up with different ways to extract features, and I explained in the I lecture, right? For a computer vision problem, for example, if you are after certain object classes and you try to identify, for example, edges, color, the texture, for example, there might be something that best describes something that you are looking for, or something that you want to distinguish from the other objects, right? So it is something that's specific to a problem, typically. So data cleaning, right? This is what you will need to spend time on in the assignment. If you might come across missing entry, you might come across entries that are incorrect, inconsistent. You might need to do something about the missing entries, maybe using values that are close to the missing values, and then try to either interpolate or impute the missing values, see what, so that subsequent data mining algorithm will not complain or perform better. Finally, if you have a huge amount of data, maybe the number of attributes is really, really large, or the number of instances also really large, then, and you have limited computing power, then you can consider reduce the size of the data. If you have redundant and noisy attributes, for example, you could also try to remove them, right? I will discuss it a bit more when it comes to the assignment, because in assignment you have different ways to analyze if a particular feature is useful for a particular class, right, that we are interested in. All right, feature extractions, as I said before, right? So, all right, so let's talk specific about different types, right? So if you have sensor data, right? Sensor data means you have something like a sensor that capture the temperature of outdoor temperature, and it records a value every seconds or every minute, right? Then together, put them together, you have a what I call time series data. And how can we analyze the time series data? There are different transform that are typically used, for example, Fourier transform or Euler transform. Of course, I won't have time to explain how the transform really works, but intuitively, right? If you have a time series data, it can analyze the frequency, right? The distribution of short-term frequency over time. And the frequency is the representation of the behavior of the time series, right? For example, whether the changes in the values are happening really fast, or the change is slow, it is smooth, or is it noisy, right? Everything can be captured in certain transform, for example, Fourier transform or Euler transform. If you have image data instead, then you can look for corners, edges, like color histogram, texture. If you have web logs, basically the logs of people accessing websites, then you can have text strings in pre-specified format and so on, right? So what else? If you have a network traffic, then the raw data in this case is traffic packets, right? So traffic packets, they have specific format, maybe, and they'll contain routing information. One of which example that you can obtain from is the KDD COP99 intrusion detection dataset, which is very famous. So you can look for, if you're looking for a certain network communication, you can look for duration, protocol, service, source, destination, right? So these are already captured in the dataset. Now, documents, right? Documents, for example, you have a basic term document matrix, which we mentioned briefly in the first workshop when we talk about the clustering of documents that belong to either science or sports, right? Or you can use some advanced feature extraction methods, for example, looking for bigrams and trigrams or name entities, right? They are special collections of words that can represent some semantic meaning. In XML documents, they are structured documents, and therefore tree-based representation might be the a good way to represent a document, right? So because if you want to exploit the structure within XML documents, right, then you need to have some suitable representation. Okay. All right. So the topic that maybe of more focus is data type portability. Right. So the bottom line here is that we may encounter different data types in different data mining tasks, or maybe a combination of different data types. And sometimes we would like to convert, right, from one data type to another data type. Maybe it is more convenient for the analysis, or maybe it is required by a particular data mining method. So for that reason, we have to do the conversion between different data points. Now, what I would like to do now is that we have data type conversion, right? So from numeric to categorical, and the choices are equi-width, linear, equi-log, logarithmic, and equi-depth, uniformly distributed, right? One of the goal that I have to make sure is that you need to be able to distinguish between different choices, what they mean in practice, because conversion from numeric to categorical is something that you are likely to do on a regular basis. So you have to understand how that can be done. From categorical to numeric, right, you have binarization, which is to convert one numeric attribute to multiple binary attributes. And I explained in our lecture, right, that convert from one categorical value to numeric requires a number of bits, right? So in this case, we have 3 bits there, 0, 0, 1. So the reason for that is that it gives you a better mapping, right? A more meaningful mapping from categorical to numeric. text to numeric, right? This requires a little bit of linear algebra, but essentially, right, what we are going to do then is for text. So text, what it takes really, text is basically, if you talk about a document, right, it consists a number of words in the documents, and if we ignore the order of how the words appears in a document, then we can capture them in a matrix, right? And what is sorry, in a vector, and in a vector, which means that each entry encodes the occurrences of a particular word, right, in that document with respect to a particular reference, and reference is basically what I call a lexicon or dictionary, right? So that we have seen in the first workshop, but further, I guess, step can also be done to reduce the high dimensional and sparse nature of the vector original representation of the original data. So what happened with semantics analysis is that we can reduce the dimension considerably. For example, a dictionary or a lexicon, right, can have 100,000 words or 100,000 dimensions. If you represent a text document using every word in a dictionary, first of all, the dimension is going to be huge, right, 100,000. Secondly, it is very sparse because lots of the entries are actually zero, and very few entries are actually non-zero. So that is the reason why we have to use LSA or latent semantic analysis to reduce the size of the representation, right? So we typically end up with 300, few hundred dimension. How can we do that? It is done through something called singular value decomposition, right? I'm not sure if any of you are familiar with that, but it is a technique in linear algebra that can identify principal variations in a data and then project the data to this principal direction. And we also have a document term matrix, which is basically a collection of all documents with normalized word frequency, right? Time series to numeric. What we typically do, trying to do, is to remove the dependency between original time series values. So, as I said before, when it comes to time series, right, we need to use some sort of transform. Transform means that we can capture the variations of data over time. Things like Fourier transform or Weber transform could be used to capture the variation in an efficient way, right? So this is what we use for encoding video, images, and so on. So by capturing the variations of the values, then we can describe time series more effectively, right? Because in the raw data, then it is very hard to see. For example, if you have if in the speaker recognition sort of application, you want to recognize a particular speaker, right? For example, in security, you have a system which if recognize the voice of a particular person, and if it is not that person, the system won't let that person in, right? But it has to be the right person who is allowed to access. So if you look at the time series, which is the waveform of the audio, then it is hard to see what's going on, right? So you have to transform using wavelet into Fourier, and from there, when you go into the time domain sort of a representation, time frequency representation, then it is easier to see the speech or the audio as some image, and from there you can clearly see the difference between different, I guess, speakers, right? So you can distinguish between the speaker which is allowed to access and the speaker who is not allowed to access. All right, from discrete sequence to numeric. So similarly, similar to categorical to numeric, right? So we have to convert each symbol to binary time series, and then because we have a number of possible values, so we have to have a number of bits to represent, and from there we can put them together to analyze. Okay, so that is the second topic. All right, so let's now have a look at the second tutorial to make sense of this topic. Let me try to find where the tutorial question. Data preparation, that's the one. Okay. Oh, Kevin, okay, you are still confused. Okay, would you like an explanation? All right, so oh yeah, okay. Let me try to give you an example. Let's just say we try to analyze a in speech recognition. Speech recognition is probably the best way to describe it. So give me a moment. May I just search a okay, so give me a moment. All right, so give me a moment. Okay, okay, let me. All right, so I have a request here just to explain a little bit from time series to numeric, right? So it is about how can we analyze the time series to something in a vector representation. So let me try to sorry, share file. Sorry, not share application screen. Chrome tab. All right. Let me see. Give me a moment. So, all right. So this is basically a Wikipedia, right? Because on a topic of spectrogram, which is similar to, or actually the same sort of category as. So what we typically have is this one, all right? So can anyone see things on the screen? No? Yes? All right. So if you look at the so this figure has three blocks, right? The top lot represent the time series, which is a signal in the raw domain, right? A raw signal in the origin in the time series. It's basic time series. Why the time series? Because you have maybe 1,500 samples, so they are, I guess they are, between -1 and 1, so they represent the amplitude of an audio signal. So our goal is to analyze this audio signal, and suppose that we are interested in classifying whether this the speech or the audio here is produced by an authorized person, right, versus the speech produced by another person. So it is a classification classification problem, right? Of course, we assume that we have sufficient training data, and given a particular signal, we have to decide. So, how can we deal with this data? Obviously, if you need to deal with this data, then it is really challenging, because the way that the data may be captured with translation, right? Translation means the exact starting time we don't exactly know, right? Maybe it start from here, maybe it start from here. It depends on how. So any translation error could produce a problem if you rely on it too. So we need to have something that might be less sensitive to translation problem, right? And in the raw data, right? If you have a person speak maybe even the same word, for example, data mining, right? Maybe different time, it will look totally different. Right? The values are not the same, right? And therefore, relying on the original values here is not reliable, right? People have found that in terms of speech recognition or speaker recognition, right? In order to better represent this, we need to perform some transformation from the time series to something that is more meaningful, right? How can we do that? What we are going to do then is that we have basically something like we're running a transform, in this case a discrete transform, which produce a matrix. Initially it's a matrix, but we can concatenate and then we can produce a vector. But what it analyzed is that it did analyze at different frequency bands, for example, right? So this is from maybe this is from high, this is from low frequencies, and then you can see the components of that through the transform. And if you represent this in this representation, right, some contents of this representation will be less sensitive to the translation. So this is what I call the this is the image plot, right? By the way, this is the image plot of the coefficients of the transform. In other words, the result of the transform when you apply on this signal, right? So maybe the darker the value, so that the darker the color, the smaller the values, and the brighter the color, the larger the values, right? That is normally the way. And then if you perform further analysis, then you can collect them together in a vectors, and in a vector that will have a specific meaning for each entry. And that's how we deal with time series signal. So now we can represent in a vector, and the vector could have meaning, for example, at this frequency, what is the energy in that frequency band, right? So regardless of whenever it happened in this window. Okay, I'm not sure if that's a good to express that, but of course, if you are interested in transform, then yeah, so this is another example of a male voice saying ta ta ta, and then by you look at the distributions of the different bands here, then it is easier to distinguish one from another. Okay, now I'm going back to the tutorial question, and hopefully we can solve some questions today. Okay, discrete question to numeric. Okay, that's a very fairly good question. All right, so this discrete sequence to numeric is also in the same way. So what you are going to have as a, okay, let me go back to the slides here. The preparation. So if you look at this slide, sorry, not this one. What are we? No. All right. So what we have here is that we have to converge X. The first thing is that, okay, with discrete sequence, right? With discrete sequence, we are not going to be able to do something on that straight away, because it's hard to manipulate nominal attribute or nominal values. So we have to convert to attributes. So let's just say you have a sequence IBC, IBC, for example, right? And you have to convert that into something called numeric. What you can do then is that, first of all, let's just say you have 3 symbol IBC, right? So you know that Is there any way that I can actually write or draw? Okay, maybe I can just, okay, let me just stop this for a moment. Maybe how can I do a whiteboard? Blackboard here. All right, so let's just say you have, let's say you have a symbol I, you have B, maybe no, sorry, no, maybe something more better like this. So you have ABC, 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 right? ABC, for example. Okay, and it's suppose this is long, all right? Is it? Hope that is clear to everybody. So remember that what we can have is that we can represent I as a how can you say it? 3 bits, right? So A is probably 0, 0, 1, and B is 0, 1, 0, and 3 is what do you call it? Yeah. So I should be okay. How can I write this? I have to have different rows. Well, let me put this way. So I, right? So from I here, I will represent it as a 0, right? 0 and 1, right? And B here is basically 0, 1, 0. Okay. C here is 1, 0, 0, right? Does it make sense? So remember, this is one dimension, right? But now it becomes 3 dimension because the conversion from categorical to numeric. So if you repeat the same process, then you have at least one time series here, another time series here, and another time series here, right? And this the first time series here consists of value of 1, 0, and 1, 0, and so on, and 1, 0, and so on, right? I keep repeating. Okay. Now you can do the same thing. So at the end of the day, what you end up with is you end up with having 3 different time series, right? So this is time series 1, time series 2, and time series 3, right? So as the lecture slide suggests, because you have 1, 0, 1 here, they are numeric, right? So what you can do now is that you can apply the transform to this time series, you get some result. You apply the transform to this time series, you have another result. You apply this time, you have another result, right? And then you can aggregate or basically put them together in a giant vector. So for example, from here to maybe you can apply a window, for example, and you perform the transform, and then you can convert, for example, the first one is this, and the second one is this, for example, and the last one is this, right? You can put them together in a giant vector like this, for example, and this is the representations, the numeric representation of this time series. So it, first of all, right, generally it is smaller size, as you, if you ever play with it, right? And secondly, it captures all the sort of behavior, right? The statistical behavior of the original discrete sequence. So for example, how often it changes, is it smooth or is it very noisy, right? So it can be captured by different coefficients that are found in these vectors. All right, I hope, Vincent, maybe that's, sorry for my very bad drawing, but I hope that's give you an idea what the transformation or conversion from one to another. All right, so let's go back to the question now. The first one is data preparation. All right. All right, what I would like to do, oh, what's that? All right, so missing entry, we do that a bit later. Let's see. All right, so this question one we do later, question we do later, right? What I would like to focus now is on question number 5. So this will make sense of conversion from what I call it, numeric to nominal, right? So originally we have a numeric attribute, and then this is what I call a histogram, or the distribution of the attribute, what for those of you who are not sure what this means, let me just try to explain. So what we have here, we have an attribute that has different instances, and then we measure the value for different instances, and we sort them maybe from large to small, and then for each values, and then we identify the interval, for example, and we found that from 2022 we found 10 instances. From 22 to 24 we found another 10 instances, and so on, right? So this is what I call the histogram of this attribute. Suppose that we want to convert this attribute from nominal to numeric. What we can do is that we can divide the range of, which is what the question say here, low, medium, high. I think that's what it say. Yeah, sorry, a low, mid left, mid right, and high, right? And the question then is, if you are given two schemes, one is equi-width and the other one is equi-depth, right? You have to fill in this table. So if we divide the interval divide the range into 4 intervals, right? What should be the starting point and end point of each interval correspond to either equi-width or equi-depth, right? Of course, you have to listen to the iLecture to understand what equi-width mean and what equi-depth mean. So essentially, equi-width means that the interval is equally divided, and equi-depth means that in terms of the distribution, right? Each interval will collect the same number of samples. That's all they mean. All right, now, so I would like you to, if you have attempt this question, I'm more than happy to look at your solution, the answer to this question, and I will tell you whether you have the answer correct or not. But if you haven't attempted this question, then all right. Oh, okay. So I have two quick answer. All right. So I'm not sure what scheme you are talking about, but let's just say equi-width first, right? So the range of values that we have here is from 20 to 44, right? So which is basically how many blocks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different blocks, right? Each block is basically 2 units. So you have 12 blocks and you divide by 4, right? So that give you 3 blocks each. So the first one should be this block, which is 3. So 20, 26. Yeah, that's correct. And then the next one is 26 to 32. And the next one is 32 to 38. And the last one is 38 to 44, right? So yeah, so I think I have two correct answer on the screen. Yeah, thank you very much. Okay, so for those of you who have attempted this question, this part of the question, you can compare your answer with the answer given on the screen. That's correct. How about equi-depth? If you have to make sure that each interval covers the same number of samples, right? How can we find out the starting point and the end point of the intervals? All right. Yeah. Thank you, Nahal. You have. All right. Can you explain how you can come up with that answer? I mean, if you can speak, that could be great. Oh, we have two different answers. Okay, so 30, 32. Okay, yep. Okay, I can't really tell. Yeah, but can you explain how did you arrive at that answer? That's more important than the actual values. Okay, yep, so I can listen. Yeah, so each section has 100 occurrences. How can you find out that each section has 100 occurrences? Based on what reason? Yep, we need to calculate the total, right? So what is the total number of samples that we observe here? 400, right? How did you find out 400? Can you explain to the class? All right. Yep. So that is the information that I'm looking for. So a couple of students have identified that first of all you have to work out the number of occurrences. How do you find out the number or total number of occurrences? By basically looking at the number on top here. So the number on top here represent the number of occurrences in which each of the blocks. So we have 10, 10, 30. 10, 10, 30, 40, 60, 100, 10, 60, 30, right? So these are the occurrences. You need to sum them together to find out the total number of occurrences. So from there, if you put in a calculator, or if you can do that, by hand, then you can work out that is 400, right? So because we have to divide 400 sample in 4 different intervals, so 400 divided by 4, you come up with 100, right? So that is the number of occurrences in each interval that we need to find out. And you can go from left to right, from right to left, right? Every time you collect 100 sample. So from left to right, for example, the first one start from 20, right? We go to 22, we collect 10. If we go 24, we collect another 10, which makes the total 20. That's not enough. We keep going to 26, another 30, which gives us 50. That's not enough, and keep going, right? Until you get the first one is 32, right? So if you reach to this point, maybe I should draw something. Draw. All right. So if we reach this point, then the first interval is from here to here, I suppose, right? So that will collect 100 samples or occurrences. I hope it's clear to everybody. All right, and the next one we start from here because 60 and 40 gives you another 100, so that will the second interval is from this one to this one. All right. The third interval is already 100 here, so it will be from here to here, another one. And finally, from here to here, we have another 100, right? 10 plus 60 plus 30. So the answer to that question is that if we use the equidepth approach, right, the intervals are not do not have the same length. They are different, right? For example, this one seems to be larger because because it needs to collect more sample, and in this region, right, the data is distributed very sparsely, whereas in this region is more concentrated, right? So that is one thing that you can do. So this region has more concentration. That's why it's smaller, right? And this one is probably in between. All right, so is it clear to everybody? Equidepth and equiwidth. This exercise to highlight that the difference between equidepth and equiwidth, right? Now the next question is, let me just try to magnify. Any other conversion? Okay. So another question here on conversion is all right, question number 3. All right, suppose that you have a data set, right? Each data point corresponds to a sea surface temperatures over a square mile of resolution 10 by 10, right? In other words, each data contains a 1010 grid of temperature values with spatial locations. You also have some text associated with 1010 grid. How would you convert this data to a multi-dimensional data set? All right, has anyone thought of this question yet? All right. So what we have here is a very, very specific application. We have a sensor, right, which measure the temperature, and here we also have this data point, right, data set, which data point correspond to a sea temperature of a square mile of resolution 10 by 10, right? So data point, each data record contain a 10 grid of a temperature with spatial location. First of all, right, I would like to ask you, right? So each data here, right, consists, refer to a 10 grid. So what we have is, yeah, okay, someone has a suggestion. We create a table with 3 columns. One column would be the coordination, temperature, and the text. Would it work? Convert to a multi-dimensional data set. I think what you're trying to do is you're trying to represent it in some let's say 3 columns. One column will be the coordinates, right? The second is the temperature, and the third one is the text. Yeah, it's but with this with this question here, we are really talking about converting basically it's more like a how can I put it this way? We have discussed one in the case of one-dimensional time series data, right? If we have a time series data, then we need to use some sort of transform to convert that. So here we have actually a generalized version of exactly, yeah. So think about this as a an image, right? Think about it as an image. So here we have each record refer to a particular parts of the image, which we typically call maybe so you have an image here. Maybe I can just, I'm not sure where can I draw. Probably I can draw somewhere. So you can have an image here, for example, and the image here basically is it the sea? Yeah, the sea, for example, right? So you have a particular location of interest here. So in a location of interest here, you have a record, right? So what this record is, basically you have a I'm sorry, I have to write this over here. So you have basically a detail of course, you have a multiple location. Maybe the sample is here, another on the sample is probably there. So the marine scientists may collect data from different locations, right? So for each different record, you have I'm drawing here 4 by 4, but it could be I guess 10 by 10, right? From the question is a 10 by 10, and the size of here is 1 mile, right? Now. Okay, so what we have here is according to the information, right? We also have the text, I guess ABC, whatever the information associated with this location, right? Now, one answer that I have received so far is would create a table with 3 columns. One column would be the coordinates, this and the temperature, and 3 text, right? Would it work? The question is that, hang on, the question is how could you convert this data into a multi-dimensional data set, right? So your suggestion is 3 columns. One column would be coordination to temperature and to text. It doesn't work. It would not work because you have lots of values in here, right? So 10 here, for example, remember when we collect temperature, right? We have a 10 grids, and then this is basically values, right? Yeah, you can have 3D arrays. Yeah, that might do. But in data mining, right? So in the data mining, what we are actually defining here is basically multi-dimensional, right? And when we say multi-dimensional, what we really like to do is that we like to have like a vector format. So vector is like maybe if you have ideally what we would like to have is basically from here, right? With the text here, what we come up here is basically a row vector, right? With entry here from different. Maybe I have to use my touch screen. Anyway, I use my mouse, so it doesn't look great. But so from here, what we would like to do is that we have to convert to something like this, right? Now, this question here is relevant to time series to numeric, right? So what we're trying to do is trying to convert this to this kind of form, right? So one suggested approach that is described in the textbook is that from here to here, you need to run basically something like a transform, right? Transform from this to this. The reason for that is that because the nature of picking a location and get a grid on top of it and run, and similar to what I said before, what you are interested in is to look at the overall behavior of the temperature in this location, right? So what you might want to do is that you run a generalized version of the transform. So we look at Fourier transform, Weber transform before. It is I use the example in Wikipedia for 1D, but there's a 2D version of it. So you can run the transform, collect the coefficients and put them in here. And how can you you can also take into account the text as well, right? The text data can also be represented in the sort of vector format, right? Remember the vector, the text is, let's just say you have a lexicon, right? And the lexicon will be used to represent a text with an entries, like 0, 1, 0, 1, or whatever, right? Depending on the number of words found in the text, right? Does it make sense to everybody? Right. So here you have another one, and you can somehow, put them together or create them and put in this multi-dimensional vector. So that is what the question expects you to come up with, right? And of course, you can run SVD latent semantic in analysis to further reduce the size of this, right? So this question is really relevant to the part of the slide. We talk about converting from time series to numeric, right? That is the expectation. Or from text to numeric. Okay, so I hope that that give you an idea. Yeah. So of course, Weixin, if you can look up for 2D discrete Weber transform, let me try to. Yeah. So in 2D. Yeah, 2D. Yeah, 2D. It is a lot in image processing, image compression, right? So if you look for discrete Weber transform, for example, from Wikipedia, there's an example of that in the image processing context. We encode image using 2D transform, and this is one way to do that. So you can imagine this is basically a picture, right? 10 by 10 grid is a picture. What you are trying to capture is that you can capture the Weber coefficients when applied to this little image, 10 by 10 image, right? And then you capture the coefficient and you put them in an array or in a vector, right? I have a question here: is data spatial or time series? The answer is that it's both. Spatial data, Tabitha, because here we're talking about temperature values distributed in the ocean, right? Or I think 1 mile. So so you have a location and you have different sensors and they capture, for example, temperature at this point, temperature at this point, temperature at this point, temperature at this point, right? So for each location, for example, Perth is one, Rockingham is another one, Albany is another one. So we have different temperature values in different locations, and then from there we can get an idea of the local, the distributions of the temperature in the ocean. Oh, it is spatial, correct. I think what I'm trying to say is that it's similar to time, because as I said before, time and space, they are from my point of view, they are actually similar, or in fact the same, right? So there's no time here, but they refer to the the given location. All right, so okay, can you start? Okay. Okay. Okay, I will. Okay, can we have a whiteboard? Where's the whiteboard? Whiteboard. Okay. All right. My apology. I will probably start again, right? So to make sure some people still are confused. So suppose that you have an ocean which looks like this. This is an ocean, right? So an ocean that you can select. Maybe this is a location, one location. This is another location you want to sample from. I mean, if you are a marine scientist, you might have different interests in understanding the temperature variation. So you have location A here, for example, location is B here, for example, and this is location C here, right? So each location, you have number of sensors, and you capture the temperatures, and then in the record, right? Maybe it's sitting somewhere in a database, right? You have two things, right? So first of all, you have the 10 by 10 grid, which looks like this. Of course, I'm drawing 4 by 4 because drawing 10 by 10 is going to cost me a lot of lines, right? But I hope you get the point. And I also have the text, right, which contain maybe there's some special IBCD, IBC, right? So about the location, right? So I hope that makes sense. So what we are interested in that is how can we how can we represent the combinations of temperatures values and text value here in some format that we can, for example, classify. I don't know, in marine science, we might want to classify with different marine region. For example, might be warm sea or cold sea, for example. I'm guessing really. So how can we do that really? Of course, you may try. Why can't we just basically put them together in a from this, for example, you just convert to a row, right? That is possible, but it's not going to give you meaningful result, because remember, this is like an image. So if you want to analyze the image, you better use some transform that can capture the behavior of the temperature values. So in image processing, for example, if you want to compress an image, for example, you might just want to apply some transform on it and get some coefficient, right? Similar to time series that I mentioned before. So what we're going to do is that we apply the Fourier, some transform, maybe 2D transform, and then from this we get a number of coefficient, right? So what does the coefficient look like? Maybe if you use something like a discrete Wahlberg transform, it will look like you have a multi-scale, for example, and then you have if you look at the Wikipedia, you have something like this. So this is the detail scale, for example. This one is another one, and here you can perform another transform, you get another one, and you can have another one like this, right? So each of these give you some sort of coefficient, right? Coefficient here, coefficient here, coefficient here, right? And then you basically collect these coefficients together. This one here, probably you put, for example, let me say this part here, this coefficient you put here, right? So that's one. This here you put here, another one. This coefficient here you put here, another one, right? And same thing with the other one. This one here you put it here. This one here put here. This one here you put here, right? And so on, right? So we now collect. We can collect all the coefficient of the transform in the first part of the row or of the multi-dimensional representation, right? In the text representation, we know that this one here can be represented by, let's just say, a numeric representation, which we have something like, for example, if you have a dictionary of, let's just say, ABCD, for example, that we can say, well, A, right, appears maybe 2 times, so you have 2 here, right? B appears 2 times, maybe another 2 there, and similar C appear maybe 1, there's 1 here, right? And maybe you have some other symbols or some other words, and you could have potentially more lots of 0, right? So this is basically a raw representations of text, right? Now you might just want to apply some, as I said before in the slide, it can apply latent semantics indexing, for example. Sorry, so LSI, for example, latent semantic analysis, because potentially there could be 100,000 dimensions, right? Lots and lots of values in here. So what you can achieve after apply LSI is something like 300 dimensions, right? And then they contain some values in this, and finally you can put this next to the one that you have produced, and it could be something like this, right? So at the end of the day, the multi-dimensional representation is a collection of both text and temperature, which is this part. Okay, sorry for my drawing, not very great, but I hope you get an idea. Is it clear? It's just a combination of what we have discussed so far. All right. If there is no further question, then we move on to the next topic. All right. So in the next topic, what? Yeah. Oh yeah. If you play around with the time series a lot, you can understand that more easily. Of course, you may ask why we have to run the transform. Well, it's hard for me to explain, in a workshop like this. But if you want to know more, I'm more than happy to send you a few references that you can read further. Or I think in the textbook the author explained that quite a lot. But what we normally do in in image processing is to apply some transform to capture the data even better. All right. Do you need to memorize? Well, the main conversion that I described there, then I expect you to read through and understand. And if you are asked, then you should be able to know. So, okay. All right. Let's moving on to the topic of handling missing entries in data mining, right? So as you might come across example where they are missing entries. What we can do with them is either we can discard them, we can impute them, or we can accept them, right? So depending on what you are going to do, right? First of all, but one important thing that I would like to discuss now is when you can discuss the entries, when you should perform imputation, or when we can accept the entries, right? So discard, as always, we already discussed if it's not going to cause any problem, right? If you discard it and it will cause problem, then it's not going to be good, right? So, for example, if you have small fraction of item with missing entry presentation, so you say, well, if they are in the, for example, the training set, and they're not going to give me, problems, and maybe I can discard them, right? Or you can say, well, what about if I try to replace them with some value, for example, average, global, or locally, right? So you can use techniques like interpolation, extrapolation, randomization, and so on. Okay. Now, an example, what I have here on my screen is for those of you who already attempt the practical exercises, then you know this. But what I'm doing now is I'm sharing my screen. Where is my screen application? Okay. So, all right. All right, so what I'm showing you here is basically the exercise 2 in the first prac, right? For those of you who have done it, you already know what it is, but here we have the data set from the competition, right? And I mentioned before, this is from the Titanic competition, predicts the survival ability of passenger, right? So if you can look at if you can go through the data set here, then you can look at this part of the Explorer interface. Look at the missing there, P class, no missing, right? Sex, no missing, but age, right? There's some missing information there. 263, 20%. This one is 0%, 0%, 1, right? Only 1. So cabin, a lot of information missing there. Embark and survive, right? Survive missing it because you have to predict the 418 sample, right? Part of the competition. So by the look of it, right, when I go through the different attributes and the missing there, then I can define maybe fair, right? Has only one attribute, right? So has only one attribute out of, one instant, right? Out of 1300, right? So maybe that is something that we can discard, right? Depending on what the value it is. So maybe this is not important at all, but depending on where it is, right? So that's what we can sort of make a decision. Okay. Whereas if you have some other significant number of missing instances, for example, did I have something more significant? Something 20%? Yeah, 20% that I said before, right? 20% age had 20% missing values. Then it is quite significant, right? If you discuss them depending on the problem that you are trying to solve, maybe that will constitute, you remove a lot of instances, and that is not going to be good. So you might consider maybe doing something else about it, or replace with average or not, or maybe do something about the attribute, right, rather than removing the instances corresponding to these missing entries. Okay, so I hope that you could get an idea, right, about when dealing with data. Files again, go back to the. Okay, now where are we? All right, interpolation and accept, right? We are not going to see a lot examples like this in this unit because it requires advanced maths. But it is known that if you have the ability to model the missing entries in, for example, matrix completion, for example, right? Then it is possible that you can accept the missing entry and treat it as part of the problem, right? And you can try to recover through the formulation or the construction of the model. As missing entry, the next topics, right, is what about incorrect and inconsistent entries? So this is more domain specific. You have to detect them from domain knowledge and correct them if required, or look the data and look at the distribution and identify if they look like abnormals, right, or outliers, and we can correct them accordingly. The other techniques is basically scaling or normalization in the language of Weka, and standardization, right? So what are we going to do with this is the aim is to bring features that have vastly different scale into some fairly comparable basis. For example, if we have salary and age, right? Salary, as I said in the lecture, can vary from maybe a couple of thousand to 100,000, 200,000 or more, right? Whereas age, you are likely to observe value, typically between 0 and 100. So they are not directly comparable. If we mix them, chances are salary will dominate, right? And then influence more on the final decision. And therefore, we need to perform suitable preprocessing methods, either normalization or standardization. The difference between the two is that one, right, standardization, for example, will bring the value on roughly half negative, roughly half positive, right, around 0. Whereas in scaling, min-max scaling to 0, 1, which is normalization, with this formula, we will bring all values to the range between 0 and 1. Right? So this might have some advantage when you require the values to be non-negative, right? But otherwise, this standardization can also work well in practice. So the choice is really up to the person who performed the data mining task at hand. So how does it really work? Let us see them in action. What I'm going to do now is I'm going to show you, especially for people who are using Weka. Maybe next week you can have the you can start working on. Okay, where's numeric? All right. So age here, for example. Okay, let me try to share once again. Go back to Weka. Sorry, share screen. All right, what I'm going to do now is once again going back to the Weka example. All right. Is it shown? Yes, it's shown now. Hopefully shown on the screen. Now I'm looking at the Titanic data set again. This time I'm looking at the age attribute, right? And you can see from there they are all right. The values actually ranges from. Can anyone read from the histogram and tell me what the range of values are we seeing here in this plot? I would like you to pay to the range of values. What is the minimum value that you can see for age? Yeah, thank you, Jeff. Yeah, thank you, Andy. Yeah, so 0.70 to 80, right? So suppose that we have another attribute called maybe salary, right? I don't have it here, but what we like to do is to convert that or to scale it, right, to 0 and 1. How can we do that in all right, so where is it? So in Weka, what we have here is for those of you using Weka, right? Of course, for those of you using programming, you can use some other methods, but this has to do with attribute, and this is called normalize, right? So you can apply on this, for example. So if you click on this, right? So normalize all numeric values in a given data set from the class and so on. So if I apply on this, right? Now pay attention to the range, right? If I apply now, then you can see that now okay, where's the age? Yeah, so you can see that the minimum now becomes 0, right? The maximum now become 1, right? So if we have salary as well, is it age? Oh, sorry. All right, thank you. All right, so so the things become 0 is 1, right? Okay, maybe what All right, so what I would like you to do now is what I'm going to do now is I undo that, right? So this is keep jumping, right? So this is the original distribution, right? What I would like you to do is to pay attention to the shape of the distribution, right? This is before I apply the normalization, right? Now, if I apply a normalization, maybe what I can, I'm not sure. You pay attention to the distribution, right? Look at the shape of the distribution. Now, if I apply, and I got H again, right? Of course, the maximum value and the minimum values have changed, right? From something, 0.17 to 80, and now it becomes 0 to 1, right? So that's the first thing we notice. Yeah. What about the shape? Yeah, the shape is the same, right? So that is a very, very important property, I would say. The scaling and normalization or even standardization, as you will explore, right, will maintain the distribution properties or the shape of the distribution, right? It won't affect the shape of the distribution, which is good because we don't want the transform to mess around with the distribution of the data because it will, it will not be good, right? So so this is called a linear transformation, and typically linear transformation preserve the shape of the histogram. That's what we would like to have with linear methods, right? All right, so next thing I would like to ask you, which I asked you in our lecture, right? If I press this button again, what will happen? Do you think that I will see further changes? No, okay. Say same. Why do you think it's no? Would that change the maximum and minimum value again, or would that stay the same? Yes, it already 0, 1, right? So the main point is that if you click this apply again, you click maybe 10 times, and if you look at that again, it's still there, right? Still 0 and 1, because when we have normalized the attribute, by definition, you can look at the formula and you can find that they're actually the same, right? So that's another important property of normalization. And same thing, what I would like you to invite you to do is play around with the standardization, and you tell me whether it is still the same or is it different, right? So that's an exercise that I would like you to explore outside the class. But in the meantime, we come back to the practical questions. The tutorial questions, and hopefully we can finish off in the next 20 minutes. Last few questions. All right, consider the time series. So we have a time series in this case, right? And we have the last entry is a missing entry. So what I would like you to do is get a calculator or something and try to understand what you call it, try to predict, right, the missing entry using, right, linear interpolation on a window size of 3. All right, I think there's some question. Okay, now I think, okay, maybe I don't think we have much time to go that, but can you post a question on discussion board and I will explain that topic later, right? We focus on this time. Okay, yeah, okay, thank you. So I have a couple of answers there. We have 9, 9, 9. Yeah, so you, for those of you who come up with the 9, could you explain why you come up with 9? What is your approach? I mean, when you say with the windows of size 3, okay, yeah. So Kevin, you just rely on the fact that they are they are different of 2, right? All right. So what about I give you? Yeah. All right. So what about I give you? Of course, this is a simple one. What about I have minus 3.1? Make it more challenging, right? Minus. Oh yeah, that's what I want to ask you. What do you mean? What do you understand? Minus 1.5, 0.9, maybe 1.1. Sorry, not 1.1. I have to have a comma here. Of course, suppose I change this one, 1.1, maybe 3.2. This is more realistic, and then 5.5, and maybe 7.3, for example, right? If I have something like this, okay, not special anymore. Of course, I'm not expecting you to tell me the prediction, but what I want you to tell me is the approach, right? How can you find out the net value? They are not special, right? They're not special like the original question, the original values in the question 1. But if I give you something like this, how can you find out? Yeah, and I think there's a question here. What is Psi3 is used for? That is another interesting, right? So linear interpolation windows of Psi3, right? Can anyone make use of that sort of of that statement? What do you mean by window of Psi3? Yeah, exactly. Yeah, you only base on the last 3 values, right, in an approximation. The reason for that is we are dealing with time series, and then what is likely to happen is maybe I'm drawing on top of this one. I'm drawing here. So you may have a time series would look like this, right? It's fluctuate over time, and if you use everything to predict the future, you are not likely going to do a good job. What is likely going to happen is that maybe globally it will look like going up and down, but maybe locally there may be some basically pattern that we can find, or trend, right? So for example, in this part, for example, there's a trend that going like this way. In this part of the time series is going to be this way, right? And in this part, for example, we're going to see some this way, right? So if we're going to apply sort of trend, right? So the window size has to do with how many samples are we going to use to predict, right, a particular missing entry, as simple as that. Now, so we are given an information of windows of Psi3, which means that the model should be obtained from the last 3 sample. Okay, the last 3 sample is basically is used to predict what happened next, right? So we have to collect 3 samples to predict. What is the put it this way, what is the meaning of linear interpolation? Can anyone give me some suggestion? Yeah, linear. Yeah. So what I mean linear regression is basically assume a linear relationship, right? So a value should be a linear function of the other. So that's what we're going to have. Yeah. So what would be the answer if the decimal still? What would be the answer if the decimal point is still 9? Okay, so if we have different values, then no, it's not 9. It's not 9 anymore. It's not 9 anymore. Unfortunately, it's not 9 anymore. It would just depends on what scheme you use. And if you use, for example, a least square, for example, in other words, you have to do some sort of model fitting, right? So a model fitting is basically something that you would like to work out the best sort of best fitting curve to fit a data point. So what I'm trying to say here is that basically if you plot this value on a graph, right, then you will, if you have a piece of paper, right, you will have something like this, and all the data points in the original question will sit exactly on the lines here. They are exactly sitting on the line here. They are not off the line, right? However, if I have something like that, I will have a totally different story. I will have no longer have data points sitting here, but they are sitting, for example, 1 point sitting here, 1 point sitting there, 1 point sitting here. Sorry, 1 point sitting there, right? Now, you cannot really find a line that actually go through everything, but you need to find a line that overall will kind of go through them. But in a basically, if you have a least square sense, then you have to make sure that the line will have the minimum sum of square error, right? Put it that way. I'm not expecting you to solve this question, but what I would like you to be aware of is that if we have data sample which are not real ideal like this, right? How can we solve that problem, right? So Kevin mentioned this is linear regression is correct. Yeah, something to do with linear regression. We have to find basically some sort of fitting methods, right? Linear fitting methods to predict the next one. So the prediction should be based on what is the optimal line here that we can find that overall can fit the data. Okay. Yes, so William, that is correct. Right? So potentially I can give you lots and lots of points, right? I can give you lots and lots of points, but if you want, the main thing is that if you want to predict this point, right? If you want to predict this point, then you should not base your prediction based on the values in the past are too far away. What you should only be is basically the values of this to predict this. Does it make sense? So it isn't implying moving average of the three elements. Okay, I'm not quite clear what you mean by moving average of three elements. You might need to do something about the moving average to get the best fitting. You see to do so, but yeah, but the rule should be found from the last three elements. Exactly, yeah. So it just means we focus only on the local area that is closest to the missing entry. Okay, yeah, as I said before, I'm not expecting to solve that problem because it cannot be solved easily by hand. You need to write a program to do that, which is out of the scope of this question, right? But I would like you to know is the implications of the nature of the data. All right. The next question is, yeah, so the answer to that is 9 is the predicted value, which is correct if you come up with that, right? The next one is question number 2, right? Suppose you had a bunch of text documents and you wanted to determine all the personality mentioned in this document. What class of technology would you use to achieve these goals? Now you have lots of documents, for example, politics documents or documents about celebrities or document about places, document about organization, right? How can you find out all the personalities mentioned in these documents? Bex, of course. Kevin, this is not about, I'm not sure how it can be done, but this is about actually determine mean detect, right? Detect all the personality mentioned in the text. No, this is not this not about that. Using a filter, can you be more specific? Oh yeah, someone entity identification. Yeah, I think you're on the right track. Yeah, entity identification. I think you are on the right track. Do you know a better word for that? In the field of what you call it? In the field of natural language processing, this is used a lot. For those of you, feature extraction. Yeah, feature extraction is a general name for it. Yeah, data mining. But the actual technology that you might want to know is called name entity recognition. There's a lot of demo there on the internet, so you can have a look at that as well. So someone say, entity identification. I think you nearly get it there. In fact, if you, I think there's a MIT or Stanford, they have the online name entity recognition. Let me check. I think last time I came across. I can't find it now, but if you look on the internet, right, you can just enter a text or document. It will automatically detect all the name entities there. For example, Obama, for example, Curtin University, New York, Shanghai, Australia, for example. You input a text document, it will detect all of these, name entities, right? Entities. So the underlying technology is name entity recognition that we could use. Okay, so that's one. The next one is question number 4. I hope we have time for question number 4. So here we face a situation where we have to perform cluster analysis from a CSV file, and this CSV file has 10,000 rows or samples, right? And one of the columns has a missing entry, so you need to make a decision what you're going to do with that column, right? 2 cases, there are only 2 missing entries, and there are only 2 non-missing entries. Remember, you are performing cluster analysis, which means clustering. All right, so in the slides, what we have is that we have 3 choices. First of all, we can discard. Secondly, we can replace with some values, right? And thirdly is that we can accept the entries, right? However, we need to do something about entry rather than accept them, right? So I have some answer here. The first one is called used by William, say impute by averaging, right? And someone else say discard the entry. All right. How many of them things you are going to discard the entries? Well, just let's put it this way. There are only 2 missing entries, right? The first case, let's say the first case first, right? The case 1, what I could do with, all right, impute here. What do you think? So with only 2 missing entry, you're going to we throw the 2 entry, throw the 2. Sorry, it's not entries. We cannot really throw the entries. We have to do something about the entries. So what are we going to do that more specifically? Yep. Okay. So we can impute because they are numeric. That's certainly one choice. So can we impute in the first case? All right. So in case 1, we have only 2 missing entry, right? How many rows do we have? We have 10,000, right? So 10,000 is actually a lot, right? And 2 out of 10,000 is considered very, very, very small, which means that if you replace the 2 entry with the mean or the average, that is not going to, replace with the mean or the average. That is so the as long as you have 10,000, that will basically, if you take the average, that will represent the what do you call it, the mean of the distribution very well, and therefore you can replace the 2 missing entry with average. I think from the clustering perspective, that is not going to affect the performance significantly. It's going to be even better because we have fixed the missing entry, right? What about case 2? We have the attribute which have only 2 non-missing entry, right? Only 2 values. What should we do with the non-missing entries? So in case 2, what are we going to do? Exactly, yeah. Discard what? Okay, so someone say discard, but discard what? Yeah, discard the attribute. Yeah, discuss the column, right? Do not discuss the entry, because if you discuss the entry, that is going to be a disaster, right? So in this case, we might have to accept the fact that this attribute is not going to be useful at all, or this column is not going to be useful at all, and therefore the best choice of action in this case is to discuss the entire column or attribute, because there are only 2 values there out of 10,000, right? It's not going to be useful. So some of you have suggested that in this case, discarding the column is the way to go, right? So I hope that you can do the same thing in the assignment. If you see something that has a lot of entry, think about it and make decision whether you are going to accept, to delete the rows, delete the columns, whatever, right? Make decision and justify your action. Okay, is there any other questions? Yeah, I think that's all the questions we have for this tutorial, right? Yep, so that's about 9 o'clock now. I think that brings us to the end of the workshop today. For those of you who are using Weka, right? What I would like you to do, if you can stay there for a few minutes, right? I already said to those of you who are in the attended the practical on Tuesday, but if for those of you who are going to do it on Thursday, what I would like to do is to, all right. If you're using Weka, for example, they are what I call filter, right? Weka call this thing called filters. So you have a number of filters here that can do pretty much what we discussed today. You can have conversion of data type from, for example, numeric to binary one. You can have different what do you call it? Normalization. Where is it? Normalize, yeah, normalize one here, which is another one. You can have standardized, which is here, right? You can have or even time series delta. Okay, time series analysis. Otherwise, some other conversion, string to nominal is one here, or replace missing values, right? These you should play around with as well. Replace missing with a constant. So these filters are very useful. You should play around with them and get ready for the practical, right? For those of you who are using Python or programming approach, I'm sure that there are other what you call it, pre-processing methods. I think in scikit-learn, sklearn, right? They are listed under pre-processing. And if you look at the API, you should be able to find, for example, standardize, normalize, and so on, right? These methods are already available, and you can just follow the example, right, to transform the data. All right, so good night, everybody. Thank you very much for your attendance today. There's a question here, tomorrow session for both programming and non-programming. Okay, the answer is yes. I looked at the survey, and unfortunately, some of you are strictly, unavailable for many sessions, and therefore, it is very hard to move you around. I couldn't find a solution. So I decided at the end that I'm not going to do anything about it. If you register for a session, turn up at the session, they're all online. And then we will see, right? We will basically split each session into 2 groups and we'll attend each group accordingly. So that is the idea. Yep. Okay. Thank you, both of you. Yep. Okay, yeah, okay, sure. All right, see you. Yes, you can join any session, but